summarizing, I view the transformer as a new computer architecture that changes the way we use the computer to solve problems. The von Neumann architecture was about programming the computer. The transformer is about training a computer. I showed that the transformer can analyze any kind of sequence, not only words. It was designed originally for a machine translation. It can analyze a sequence just about anything, and it can generate, for example, images. Depending on the domain in which it is trained, it can be a different kind of foundation model. Language model is a particular case of foundation model in which the training is about a large amount of text. I repeat what I said a few times. It is designed to predict the next word in the sequence. It is not designed to be an encyclopedia. ChatGPT is a chatbot based on a particular language model called GPT 3.5. So now the number of language models is skyrocketing, but these are the ones that really matter so far. Now it starts with Google BERT and OpenAI GPT. For some reason, I forgot OpenAI GPT there, but I put GPT-2 and GPT-3. And so the size of these models is actually not the size of the data set. It's not the number of texts that tells us the size of a model. It's a number of parameters. What's a parameter? It's a little bit like in the human brain, there are neurons, and the neurons are connected by these things, synapses and whatever the axons. So the connections between the neurons, you can see that as the parameters. So so this starts in 2018. BERT had 100 million parameters. And then these things skyrocketed very rapidly. And now we are talking GPT-3 is 175 billion parameters, and it's not even the bigger one. The biggest one right now is the Megatron Turing, I believe. Palm is even bigger, 500 billion parameters. So the picture to the right, the three circles give you an idea of the relative size in billions of parameters. And BERT, if I put BERT on that, the circle for BERT, it would be just a teeny dot. So progress has been very rapid. And also how good the systems are has improved dramatically. These are famous tests to test how good their comprehension of languages. And as I said, this is I don't know how to call it. This is a new exponential law. The number of parameters doubles so far every two or three times every year. I don't know how to call this law. The law, there's Moore's law in transistors, and this is the equivalent for language models. So you have Gordon Moore in 1965. The number of transistors in an integrated circuit doubles about every 2 years. In foundation models, the number of parameters doubles every 6 months so far. Thought I had maybe later. I have a diagram that shows you the difference in the exponential. So the ghost in the machine, why does it work so well? And that's interesting because in a sense, the linguistic skills were an accidental benefit of forcing the chatbot to give a plausible answer to a prompt. And I don't think that they expected these systems to become so fluent at speaking human language. At the same time, the mistakes that we're going to see very soon I feel that they are an accidental consequence of forcing the chatbot to give a grammatically correct answer. So I think that pushing the chatbot to give an answer, and the answer has to be grammatically correct, on one hand gave us systems that are incredibly fluent in language. On the other hand, gave us systems that are sort of forced, sometimes they are forced to hallucinate, which in computer jargon means a lie. Now, Andrej Karpathy was director of AI at Tesla, and before that, I believe it was at Stanford. Besides being one of the great scientists of AI, he's also an interesting intellectual. And he published something, a paper, or it was just a blog on his blog. Anyway, he said, he started by saying, actually, we are not doing anything different. We are still using neural networks like we did at the beginning of when deep learning, so-called deep learning, is a discipline of AI, was invented. What has changed, honestly? Bigger data sets. Now we have computational, so especially computational power. Because we have more computational power, then we can have bigger data sets and we can have more parameters. But other than that, the fundamental technology is still neural networks. Anyway, now let's take a look, a closer. So there's a little mystery there why it works so well. Let's take a closer look to ChatGPT. I'm sure you've done your own test. Everything is done. But these are my selected mistakes that the chatbot did, not chat. There's a typo there. Let me write down that I have to correct the slides. How many letters in the word 5? And he said the word 5 has 5 letters. So obviously, it's a mistake that many humans could make. But he didn't make that mistake with the number 1, 2, 3, 4, and so on. Now, I asked a question about Italy. He told me a long story about Italy, and then he said that he became a member of the European Union in 1957. And I said, are you sure the European Union existed in 1957? It didn't. And so he corrected. I apologize for the error. And then he says, created a single market and a common currency, the euro, blah, 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 in 1993, which is not true. Are you sure the euro exists in 1993? I apologize for the error again. It corrects itself, and it tells me it was introduced as a virtual currency in 1999. Are you sure the euro was introduced in 1999? And then it's interesting. The euro was not introduced in 1999, but rather as a physical currency. And then he said the euro was introduced as a physical currency. So there's a mistake there. That's not true. So it ended up contradicting itself, and that's kind of interesting. If you force the system panics in a sense. And of course, it's not updated. This is well known now. You know, it's not like a human being that keeps learning. Any animal keeps learning. There's a moment where the model is created, and that's it. And so when I ask about the members of the European Union, he didn't know that Croatia is a member because it just joined recently. Now, again, it was not trained to be an encyclopedia. Google, that is closer to the old-fashioned encyclopedia, because it just looks for facts, is better. When I ask ChatGPT what happened when Garibaldi met the king, it doesn't know. But if you Google it, it comes out right away. In his famous meeting with the Vittorio Emanuele at Teano, Garibaldi. Now, these are the hallucinations. So if you want hallucinations, you have to ask ChatGPT obscure facts. I prompted L'Herbière's Inhumaine. That's a sort of obscure, silent, black and white film from, don't even remember, 20s, I think. Yeah, 24. And ChatGPT came up with an incredible story. Unfortunately, it's completely wrong. All the things that he says, I don't know where they come from. There's the scientists, the women, they're just all wrong. So then I ask again, I think the following day, and again it came up with things that, yeah, somehow related, but actually Marie Belle does not feature. She was never a singer. Leger was the designer. And even better, he mentions phonodisc. I had to really spend a lot of time finding out what phonodisc was, and God only knows why it comes out in this context. It was a British pressing plant for records, music. Then I tried to ask also funny questions, like, has a movie been made of Raponi's novel, La Luna e Falò? La Luna e Falò is a famous Italian novel, but it was made by Cesare Pavese. The chatbot is smart enough to realize it is made by Cesare Pavese, but then it comes up, I didn't ask about this. Movie adaptation was made by Italian filmmaker Pierpaolo Pasolini. He really existed, but he never made such a movie. It features this actor. I searched, Hayden never worked with Pasolini. And then he talks about critical acclaim, evocative cinematography, Pasolini's most significant work, a beloved classic of Italian cinema, except it doesn't exist. Then I ask, write a 10-line summary of Cesare Pavese's novel, The Hawk, that doesn't exist, and it gives me a very good summary. Then I tried a 5-line summary of Piero Scaruffi's novel, The Trial, and sure enough, apparently I wrote a psychological thriller, and so on and so on. And who is Mario? Mario, I don't know, my father was called Mario, maybe. And then there's a whole story there. And of course, if you know Kafka's Trial, you know where this may come from. And then the thing that is most annoying, who discovered graphene? And of course, graphene was discovered by these 2 Russian scientists. And it's not true. I mean, graphene was discovered way before, just that on the web, they keep repeating that they discovered it. Just because you repeat it many times, it doesn't make it true, but it doesn't know. So it's prone to hallucinations, to fake facts and glaring mistakes. It is obviously not designed to present accurate information, but rather what looks like accurate information. Basically, the model is trained to mimic human use of words. Oh, by the way, it writes really bad poetry. Now, this is ChatGPT is actually the best of the batch so far. As you probably know, when Facebook introduced Galactica, it removed it, don't remember, after few days because of widespread criticism. Google's Bard also, when it debuted, made some glaring mistakes. That apparently it caused the stock of Google's parent company, Alphabet, to crash. And a live demo of Microsoft GPT-powered Bing, even more serious actually, that live demo seemed to be successful. Very few people realized that the Bing made up facts. Nobody in the audience realized that that's a real danger, right? So now we have GPT-4, and Reid Hoffman, who is relatively well known in Silicon Valley, he published a book written with GPT-4, and unfortunately, I got a copy, and if you have money to waste, you can read for yourself the result. I think it's pathetic. So now we come to the risks. First of all, the risks, there are many, but I just mentioned a few. First of all, the Wikipedia effect. Who checks the source? The problem you have with Wikipedia, you find something that sounds very credible, plausible, but who wrote the article? They're anonymous, so you can never trust them. You cannot double check the statements. And with ChatGPT, the provenance stream doesn't exist. This breaks a contract between computer and user. The contract between the computer and the user for 70 years was that the computer will always provide the most accurate answer. And maybe the Google search engine already started breaking that contract, but this definitely, there's nothing in the system that guarantees this is the most accurate answer. It's just what the system comes up with by studying statistical distribution of words around the world. And the danger, again, is that people can see the chatbot as both a language speaker, which it is, and a knowledge base, an encyclopedia, which it is not. It was not trained to be an encyclopedia. Obviously, it is not able to distinguish truth from falsehood. And the problem is that a well-written false sentence is more credible than a poorly written true sentence. And this has been well known. There's an entire discipline of philosophy called rhetoric. Rhetorical speech is as old as human beings. So the problem is when they're false, they're still credible. And when they are right, they could become another type of echo chamber because they simply repeat what most people say. Of course, it is outdated within days. Any change in the world is not reflected. In 2020, they asked GPT-2 about COVID, and COVID replied that it is an LED emitter. They also tend to be amoral, not because they're bad, I mean, innerly evil, but just because they don't know the difference between good and evil. So now this has been fixed, but somebody asked GPT-4, how can I kill the most people with only $1? And GPT-4, sure enough, provided a lengthy, detailed suggestion. Now, this information is a big thing, in my opinion. These days, we talked about the pandemic of COVID. I think we should also talk about the pandemic of disinformation that we've had since anyway, the last 10 years, let's say. And disinformation spread by troll farms could be the #1 threat to democratic institutions. Yeah, let's look at here. That's an old slide. So Brexit, the election of Donald Trump, and today the disinformation about Ukraine. In my opinion, this is of course just my personal opinion, but in my opinion, they're all effects largely due to disinformation spread by troll farms. They did make a difference, in my opinion, although I will never be able to prove it. And now disinformation could escalate to new heights. Now, the good news is that the same technology could also help us double check facts. Today, for example, if you're in America, you only watch Fox News, you get, in my opinion, a lot of disinformation, and you don't get, you don't know that the rest of the world thinks otherwise. If Fox News tells you that Paris is the capital of Brazil, I wouldn't be surprised if they said it. You will believe it, because you may believe it, because who else tells you otherwise? But if you have a chatbot that looks at the entire internet, you might get the answer, hey, there's a lot of people who say that actually Paris is the capital of France. So having a chatbot could be useful also for double checking quote unquote facts. And it's also an excellent vehicle to spread propaganda, because the model contains the knowledge and the worldview of the text that we used to train it. China Daily, which is the organ, it has an English version, an organ of the Chinese Communist Party, posted something on Weibo that is actually absolutely true. ChatGPT, or any such chatbot, could provide a helping hand to the US government in its spread of disinformation and its manipulation of global narratives for its own geopolitical interests. It's true. ChatGPT is trained on Western text, and therefore it propagates the Western view of the world. This is true, and it's not difficult to predict how the Chinese will train their chatbots. So summarizing, I think language models can be dangerous precisely because they are not intelligent and because they can be manipulated by intelligent humans. That's the bottom line. So bottom line, the problem is still the humans, not the tool. Of course, a lot of people have the extreme view that language models will always be unpredictable and potentially uncontrollable, and God only knows what they will come up with. And so, in a sense, the real pessimists think of large language models as the information technology equivalent of gain of function. You know, the gain of function is in biology, now it's become a scary thing. I don't think it's a scary thing, by the way. So a few days ago, don't remember how many, 1,000 to 2,000 people signed this open letter asking for a pause in the development of these generative AI models. And some other people disagree. These are two of the historical figures in deep learning who disagree. But it's a good question how we regulate AI. You know, I see regulating IT in general, regulating software, whatever, in general, I see three ways. The Chinese way is very simple, censorship. Government decides these things cannot be done, period. The European way is to come up with a set of regulations incrementally and to protect consumers / users. And then there's the Silicon Valley way, where we just trust that algorithm, somebody will come up with algorithms that will keep these AI systems in check, in place. I don't have a strong opinion on either of these. I just know that the internet has been a problem. The world has never been so polarized, especially in the United States, but also in Europe. And I think people have never been so polarized. And one reason is the existence of the internet that has created all these echo chambers. Now, another risk that I want to name, because I'm particularly annoyed by it, I'm annoyed by the massive amount of publicity that we get these days. When I was a kid in Italy, publicity was about 10 minutes before the evening news. That was it. And now you cannot watch a 30 seconds video without getting at least 10 seconds of publicity. And a while back, a software engineer wrote that the best minds of my generation are thinking about how to make people click ads. I'm afraid it's still largely true. And I'm afraid what those best minds will do in the age of generative AI. As you converse with a chatbot, will the chatbot tell you, hey, there's this wonderful perfume, hey, or hey, vote for this candidate. Now, another issue, of course, who will own the technology? We already have the problem that the internet is largely shaped by the search engines, the social media of big corporations. And right now, if you want to train a model, you need to use the cloud providers. There are not many. And the large language models are owned by pretty much 3 companies. So we used to say data is the oil of the 21st century. It is still true. It might get through to a new exponential. The other thing that people don't realize, the language models are built on the content that people provide for free on the internet. So there's also this aspect where these three big ones end up owning the result. Anyway. So anyway, now we have also Bard, which is different from ChatGPT, because ChatGPT didn't have access to live news, and Bard is online. It knows what is going on in the world. So some of the limitation will be taken care of. Now, the mother of all risks, jobs. Of course, everybody asks, will my job be automated? So first of all, historically, I've been getting upset when I hear this question. It's a question that keeps being repeated every time a new technology appears. And I went back, I even found Albert Einstein was one of the first people to blame machines for unemployment during the Great Depression. Imagine that machines back then were minimal. Anyway. And, you know, it's been on and on and on. These are the ones I found. Machines, every time there is unemployment, machines are the first target. And, you know, lots of people have predicted massive unemployment and so on. And you do get rich. These are some of the books, and the people who wrote these books got rich by predicting the apocalypse. Unfortunately, people buy books that predict the apocalypse. What happened 8 years after the publication of those books? Well, guess what? Record unemployment. We have so many jobs, never had so many jobs. In 2009, when Google launched the project for the self-driving car, by the way, by today, the total investment in self-driving cars is $100 billion, a huge amount. Anyway, you know, when they predicted 1.8 million American truck drivers will lose their jobs, how many drivers have been replaced by self-driving cars? Question mark. I don't know the answer, but I suspect the number is zero. Number of truck drivers who lost their job, I don't know the answer, but I suspect that the answer is zero. But again, you sell a lot of copies of your book if you write 1 million, 10 million as an answer to those questions. The real question we should ask: why are there still so many jobs? Even better question: which jobs will be created? And you know, I mean, things change. In 1900, 41% of the U.S. workforce was employed in agriculture. In 2000, one century later, only 2% of the U.S. workforce was employed in agriculture. Well, did that cause unemployment? Did some farmers, some workers in Iowa, Kentucky, who knows, did they lose their job? Yeah, I'm sure. Technology has effects on all of us. You know, some of us become more valuable, some of us become less valuable. It's not only technology, just what happens in the world. When U.S. companies, encouraged by the U.S. government, started exporting manufacturing jobs to countries like China, and that has an effect on a lot of U.S. workers. So it's not only technology. There's a lot of things that have an impact on our lives. Between 1900 and 2000, what happened to the salary, to the average salary in the United States? This is in US dollars, in 2000 US dollars. Well, the salary increased 4 times. 4 times. So, so before we, yeah, so the answer is not easy because there's so many implications, but I don't think that predicting the apocalypse is good, other than for selling a lot of copies of your book. Now, the real question is, which jobs will become obsolete? Who has to go back to school and learn new skills? Actually, OpenAI published just 2 weeks ago this paper, where it shows which skills could be replicated by GPT-4. And so if you're curious, you can read the report. I didn't read the report, I just saw this picture, so I have no comment how much I believe the report, but those are the kind of things that we should discuss. There's another report that's very interesting. GPT is an early look at the labor market impact. University of Pennsylvania, this is also very recent. Very interesting because it shows that some of the jobs that could be automated easily by language models are the high-level jobs, actually. Starting with software engineers, programming and writing skills. So actually, jobs, typically people who did go to college. And on the other hand, the jobs that will not be automated by this technology are in construction, plumbing, waiters, jobs that normally we associate with lower salaries, people who didn't go to college. So I made this picture, Revenge of the Poor. And the funny thing, the picture was generated by DALL-E. So which jobs will become obsolete? I live in Silicon Valley, so a lot of software engineers now are panicking. Not the ones who work in AI, of course, the others. And this is a still from an old Italian movie where the guy to the right who is writing is a letter writer. This was a job. This was a job everywhere in the world. A century ago, not many people knew how to read and write. And so there were these letter writers who would put a little table in the street and sit there and wait for a customer to come and dictate a letter. And so one wonders, will the software engineer be remembered the same way a century from now? Now, the same Karpati I mentioned before, at the time he was director of AI at Tesla, 6 years ago started talking about software 2.0. If these generative AI models become the new way to program, the alternative to programming, actually, then we will live in the age of software 2.0, where it's not important to write the instructions of the program that solves the problem, but it becomes important to train the system to solve the problem. And that's a different kind of skills, clearly. So software 1.0 needs to be told what to do. Software 2.0 learns by itself from the data. And software 2.0, now we can add something that Karpati didn't say 6 years ago. Software 2.0 can also learn from software 1.0 written by humans and posted on the internet. And software 2.0 very soon will be able to learn from other software 2.0 systems. Now, a question that is important for some of us who have seen, who are painfully aware of the gender gap. Unfortunately, not everybody believes that there is such a huge gender gap. If you live in Silicon Valley, you see it. And if you are in AI, you see it. The vast majority of AI scientists are male. So will this software 2.0, will this new generation of transformer-based systems increase the gender gap? And I think that is a legitimate question because there are so many engineers who are male. At the same time, if software engineering becomes less relevant, maybe it is also revenge of the women, because it becomes less software engineer. The male software engineer will not make as much money compared with a woman who is working in who knows, human resources, teacher or whatever. So I don't know which one will prevail, but that is a good question. The real question, of course, is which jobs will be created. If you have children going to college right now, what should they study? Somebody just passed me this announcement for a job at Anthropic, which is one of the most popular startups right now in AI. And, it reads, they're looking for prompt engineer and librarian, and the salary is not bad. Okay, coming to applications. One application that I've seen proliferate immediately is a productivity tool. Just like the word processor of all the SQL tools did in the old days. So it can help explain difficult concepts to people who are not specialists in that concept. In a sense, it can summarize a number of pages about the same topic. For education, it can be a personal tutor, I guess. For healthcare, it could give medical advice if GPT-4 really is so good with medical advice. It can be an assistant, a coach for non-programmers when they need to do some programming. Even for software engineers, I hear in some cases they are surprised by the code that is generated by ChatGPT because it uses a different technique. It can certainly be a proof editor and ghostwriter. It can rewrite a text in fluent English, and I think this could be useful being an immigrant myself, for immigrants, for non-native speakers whose English is not as fluent as the English of people who grew up in English-speaking countries. My friend Javier is pioneering how to make movies with generative AI. He has just made this film titled Every Prompt Matters, using all techniques that come from generative AI. Making movies could be a major application, actually. Just like graphics, Pixar, I was looking for the name, and introduce a new way to make cartoons, make also films that mix live action with cartoons. This could also lead to a new way to make films. Incidentally, it could also generate many versions of the same movie. Once you give the text, it generates through a number of steps. It generates the movie, and then if you ask again, it will generate a different movie. I can see at some point that it could detect emotions. If you could see the face of my face, so it could detect my emotion. Do I like it or not? And then regenerate the movie based on that. So this could be definitely an application. Now, one of the main questions being asked in academia is the impact on education. Well, yes, students will be able to write essays more easily. I can see more creative ways to use this technology. For example, one could create generative models about specific subjects. For example, about relativity. Those formulas there are from Einstein, and one could create a generative model that is just about relativity, and the student at home could play with this model, and that would act as a tutor in relativity. I can also see, I'll talk more about this later, the idea of cloning historical figures so that the student can interact with them instead of reading about them. Let's say you have to do a research on Julius Caesar. Well, one way to do it is you Google all the pages that talk about him and read some books and try to come up with your own summary. Or you can have a generative model that learned has been trained on all these books and all these pages on Caesar, and then you ask questions, and then you interact. In a sense, you are interacting with Julius Caesar. Now the fear is, oh my God, the students will cheat using ChatGPT to produce text and so on. I think as usual, the goal here should be to teach humans how to use tools properly. That includes teach children how to use tools properly. But anyway, technology can help. There's already a tool developed, I believe, here at Stanford, that detects if the text has been generated with ChatGPT. The problem is that tomorrow there will be, in 7 years, we'll have forgotten maybe that ChatGPT ever existed, just like we're already forgetting AlphaGo. So I tend to believe more in teaching children the importance of studying rather than trying to detect if they cheat. Artists will have a lot of fun with this. I heard of an Italian artist and programmer, Giacomo Micheli, who launched a website called The Infinite Conversation. He has 2 chatbots slash avatars. One is trained on a Slovenian philosopher, and the other one on a German director. And they keep talking forever, non-stop, 24 hours a day, 7 days a week. That's also an interesting. Talking about creepy applications, you can have a model to converse with the dead. Project December made the headlines. I don't remember when, but the idea of keeping dead people alive, but having a computer simulate that person. Or even with yourself, if you keep a diary, if there is a way to retrieve all the social media posts, all your emails, you could train a generative model on yourself and then talk to yourself. Anyway, so, but right now, #1 job created by language models like ChatGPT, Bard, and so on. The equivalent of the paparazzi. Definitely a lot of people writing about this thing, and even making videos like me right now. So what's the future of these chatbots? The obvious future is to integrate the chatbot with other software tools that improve the chatbot. And I mean, the easiest kind of integration I can think of, and I think that's what Google is doing with Bard, is just to integrate the chatbot with a traditional search engine. So if you're looking for the capital of France, you don't have to guess. It's you find a page with the list of capitals. Here I put a screenshot, an application, an idea that comes from this engineer. I can read the name somewhere here, James Weaver. He put together different things, and he created a system that is, in a sense, more intelligent than just a chatbot. And that could be the future, where the chatbot is just an organ of a cognitive architecture. There's already talk of integrating with facial emotion recognition and eye tracking technology, so that it can capture the reaction of the human being. That's something that we do all the time. If I talk with you in person, I will get feedback from the expression in your face, and I will adjust my talk, even with maybe interaction, even with the brain waves. Unifor, which is one of the AI startups, just acquired a lab from Spain that specializes in this kind of emotion recognition. A major push for innovation in this field comes from open source models, and that when people talk about progress in AI, they always underestimate how much AI owns to the open source movement. Pretty much everything done in deep learning, all the way up to GPT-4, was publicly available. Each group published the results of its experiments, and other groups used it to improve. And that's been going on for a long time. So now open source, there's so many things on open source, and more things are being generated all the time. So individuals, especially in academia, can do more experimentation, and that will certainly help design the future of chatbots. I mentioned just two because they were done by people I know, by universities I know. One is Alpaca at Stanford, which is sort of a small version of GPT-3, fine-tuned in some special way, and the result, guess what, is almost as good as GPT. So it's an interesting idea. Spending very little, you can actually create something that is as good as GPT at generating text. At UC Berkeley, in collaboration with CMU, Stanford, UC San Diego, they did Vicuna. They demonstrated Vicuna, which is also based on this Llama model, and also has an even better performance. GPT-4 has just been announced, so I don't have a lot of comments. It's another multimodal system able to speak 25 languages and so on. But by the time you see this video, probably there will be something new. Progress has been very, very rapid. AIs are introducing chatbots. Probably the most popular around here is Claude. The most popular AI startup around the US, probably Anthropic. After OpenAI. Few words about China. Here from China. This ChatGPT is extremely popular in China, and so that's it has created a real frenzy to copy ChatGPT, to create the Chinese versions of ChatGPT. This is kind of disappointing because all these great students and engineers in China basically spend their time copying whatever comes from Silicon Valley instead of trying to invent the next thing. Years ago, I predicted that China would win the AI race because it started investing, as a government, started investing before the United States. Now I'm not so convinced because the Chinese are too focused on simply copying whatever happens here. And by the time they build their chatbots, will have done something new. So now one word about AI fossils. What's an AI fossil? It's the old technology. AI has been around since 1956, maybe even earlier. And many different methods have been proposed to create machines as intelligent as humans, including creating machines that speak. And so these days, those of us who've been around a long time ask, are generative models really better than other models, or simply better funded? I mean, when you have Google, Meta, and Microsoft investing in something, well, that something probably succeeds just because the amount of money. The other forms of AI don't get that much money. The question, I mean, sometimes the question is simple. Why do we have to use billions of parameters to calculate something that a simple pocket calculator from the 60s could do? You know, I mean, last year, remember AlphaGo? AlphaGo was a big deal. It was done by a Google subsidiary, DeepMind. And now chatbot is by OpenAI, which, oh my God, was founded by Elon Musk. And now it has investment from Microsoft. So, of course, a lot of attention. But last year, an AI program, I believe for the first time, beat 8 world champions of bridge. Bridge is a pretty complicated problem to solve. And this was not news. You know it only if you are in the newsletters about AI systems, and it was not big news. Well, first of all, it was not big news probably because it came from a French company. And we don't tend to know, French startups are not as publicized as Silicon Valley startups. And the technology was developed at Imperial College London by this professor, Stephen Muggleton, who has been working on that technology since the 90s, and it is not deep learning. It's called probabilistic inductive logic programming. It's a different technology. I mean, you wonder if he got the same amount of money that generative models are getting right now, what would happen?